So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a lecture on relational database model. So till now we have discussed about different kinds of database models. So in the previous lecture, if you remember, we have discussed about the network database model. So now today we are going to discuss about the relational database model. So in this database model, how the data is stored and how the model is represented and which type of data can be used in this type of model, that we'll be discussing today. So we have this relational data model. Let us discuss about the contents. What are the contents we are going to discuss today? So introduction to relational database model, key concepts, principles, operations, and examples of RDBMS. So RDBMS is relational database models. So let us understand about relational data model. So introduction to relational data model. So relational database model is a widely used framework for organizing and managing the data. So it is widely used data framework which will be helpful for the organizing and managing the data of the relational database model. So it uses the tables and it is also known as the relations to store the data, where each table is consists of rows and columns. So here the database will be stored in the form of rows and columns. So wherever you see the data will be either in the columns or the rows. So for there are different components and the principles of the relational data models. So let us understand what are the different principles and the components of the relational data models. So key concepts we'll see about the tables and relations. So in this we'll see structure, schema, and rows. So in tables, if you see the structure is each table consists of rows, records, and columns and the attributes. And this is the structure that it has a attribute column, it has a rows, and it has a columns. And schema, if it is defined the structure of the table, including the column names, data types, and the constraints. So it defines the structure of the table, it defines the column and the names of the table and the constraints. So in rows and tuples, so each row represents a single record in the table, and each row contains the value and each column in the table. And further, if you see about the columns and attributes, each column represents a specific attribute of the record. Columns has a defined data types and has an integer and char or date. So this all informations can be given in the form of the columns of the table. So what are the primary key? If you talk about the primary key, the unique identifier of each row in a table is the primary key, and it ensures that no two rows have the same primary key and the value. So this is what we have to see in this. And the foreign key, a column or a set of columns in one table that uniquely identifies a row of another table. So column is like it's a set of columns in one table which will be uniquely identifies its rows in another table and establishes a relationship between two tables. So each table is uniquely identifies a row and another row, another table, and it will establish the relationship between the two tables. So what are the relationships here? One-to-one relationship, a single row in a table. A is linked to the single row in the table B. So one-to-one relationship is the A in the single row in a table A is linked to a single row table B. So one-to-many relations, if you see a single row in a table A is linked to the multiple rows in the table B. So A in the single row and table A is linked to the multiple rows in table B. So this is one-to-many and this is one-to-one relationship we'll be having with this relational database. That's why it is called as relational database, which is related to each other. Now principles. So what are the principles here? We have a data integrity. In data integrity, we have an entity integrity or referential integrity. So what is data integrity? Which ensures that each table has a unique primary key. Referential integrities ensures that foreign keys correctly reference primary keys in other tables. So it ensures that each table has a unique primary key first of all. So second thing, if you see that referential integrity, which ensures the foreign keys correctly reference and primary keys in another table. Now normalization. So what is normalization? It's the process of the organizing data to minimize the redundancy, and it involves the dividing large tables into the smaller related tables. Now SQL. What is SQL? Is a structured query language. So standard language for interacting with the relational databases used for the querying and updating and managing the data. So SQL is what basically it is about a structured query language, and which will be helpful for interacting with the relational databases used for the querying, updating and managing the data. It helps us to updating and managing the data. So whatever data is available, it will help us to update the data, manage the data. And structured query languages is a programming language. It's a programming language for storing and processing the information in the relational database. So it will help us to program the language. It will help us to store the data, process the data information in the relational database. A relational database stores information in the tabular form. All the relational database stores the information in the tabular form with rows and columns, which will be helpful in the representing different data attributes and the various relationships between data values. Now, CRUD operations. In operations, when you see there is a CRUD option which is known as create, read, update, and delete. So this we have in this operations which will help us to create the data, read the data, update the data, and delete the data. So insert new records into the table, read query data from the tables, update, modify existing records, and delete, remove records from the table. So these are all things we can do in this relation database: create, read, update, and modify. Create is creating a new record or any new table to be added in that. Read is the query data from the tables. If you want to do some query, we can just read from the tables. Modify from the existing records. If you want to update any information, we can just modify from the existing records. Delete is to remove the records from the tables. So once if you want to remove any information from the tables, it can be removed from the tables. Now joins. Now, joins is combined data from the multiple tables based on the related columns, type of joins, inner join, left join, right join, full outer join. So these all joins are related to the each columns and the tables, which will combine into the multiple tables based on the related columns and types of the joins like inner join, left join, right join, and full outer join. Now, if you talk about the transactions, so what are the transactions? A sequence of one or more SQL operations treated as a single unit, which ensures the data the integrity through the properties like ACID. So a sequence of one or more SQL operations, like if you do some operations, single operation sequence operations, which is treated as a single unit, and it will ensures the integrity through the properties like ACID. So what is ACID? ACID is atomicity, consistency, isolation, and durability. So these are the four things which will be helpful in the transaction of the SQL operations. So what is that? Atomicity, consistency, isolation, and durability. Now let us understand what is atomicity. So there are following four commonly known as ACID. So first thing is A means atomicity. So this ensures the data operation will complete either with success, either will failure. So it has a surety that whatever it will give you the results, the sure results it will give you, it will make you sure either the data is success, either the data is a failure. So some records, whatever we feed into this operation, whatever we feed in the information to it, it will show you the success rate, it will show you the failure rate. So it follows all or nothing strategy. For example, a transaction will either be committed or be aborted. So any kind of transactions can be helpful in this, and it will be either it will be committed means it will give you the final results, either it will abort and it will give you a result as aborted. So the final thing is like it will give you some of the results that it is going to be success or it is going to be with failure, or yes or no, it will give you the information either committed or will be the aborted information. It will help you to give the information. Next, if you talk about C, now C here means consistency. So A is atomicity, C is the consistency. So we perform any operations over the data, its value before and after the operation should be preserved. So if you perform any kind of operations over the data, it is having a value before and after operation, and it should be preserved. For example, the account balance before and after of the transactions, it will show you before and after transaction should be correct, and it should maintain, it should remain conserved. So before and after transactions, it will tell you like whether the transaction is failed or either a transaction is success. So this is called as consistency, so which will perform any kind of operation over the data, and it has a value before and after the operation, and it should be preserved. So for example, if the account has the balance, and it will show you the transaction failed or it is remains same. Now coming to I means isolation. So what is isolation? So isolation, there can be a concurrent uses for accessing the data at the same time from the database. So co-current or concurrent data should be there, which will be helpful in the accessing the data from the same database. So this isolation between the data should be remain isolated. So isolation between the data should be isolated. The main data and the data between should be isolated. For example, when multiple transactions occur at the same time. So if you have a multiple transaction occurs at the same time, so what happens? It should be isolated from the main one, right? So it will show. It should show you the separate transactions here. So when the data isolation should be there and it should be remain isolated. So one transaction effect should not be visible. So to the other one. So when you do multiple transactions, so all the transactions should be in a separate manner. It should come out of the record and it should not mingle with each other, and it should show the separate transaction. One transaction should not affect the other one, so visible to the other transactions in the database. So one transaction effects should be visible to the other transactions in the database. Now D. So D means durability. What is durability? It ensures that once it completes the operation and commits the data, so it will ensure you the data commitment, or it will ensure you the ensures the data whether it is complete or the operation that commits the data, and changes should be remain permanent. So whatever changes we do in this data, it should be durable. It should not change at any point of time, and it should be complete information and complete operations which will commit the data, and data should not remain. Data should remain permanent. There should not be any other further change in the database. Now, examples of RDBMS, RDBMS is relational database model. So, RDBMS, when you talk about the examples, we have the examples like MySQL. So, MySQL is one of the example of this RDBMS. That is open source RDBMS, which known for its performance and the reliability. So RDBMS, one of the example is MySQL. So it has a known performance and reliability system, which is very reliable, and it shows its performance separately. Now, if you have a post SQL, open source RDBMS is known for its advanced features. So it is known for the advanced features and compliance with the SQL standards. So it will helpful for the compliance and the SQL standards. Now, Oracle database. What is Oracle database? It's commercial RDBMS known for its scalability and the enterprise levels for the features. It's called as commercial database. And Microsoft SQL Server. So now what is Microsoft SQL Server? It's commercial RDBMS known for its integration with Microsoft products and the services. So these are the few examples of the relational database model, that is MySQL, PostgreSQL, and Oracle database, Microsoft SQL Server, and which is very much commercial RDBMS, which is known for the integration with the Microsoft products and services. Now, example, if you see, we have some examples here. Like consider a simple relational database for the library system. It might have the following tables. So it has the examples like book tables. So example of book table, it will show you like book ID will be there, title will be there, author will be there, publisher year will be there. So it will show you the number, the serial number, which book and what is the title and which year it is published, and who is the author of that, and what is the publishing year also it will mention in the book table. So in the library system, this kind of relational database is maintained like a books table. And if we talk about the members table, so in there, if you see the members table, you have the example of member ID. ID numbers, it will show you like 101, 102 IDs it will show you, and name of the person, it will show you John Doe or Jane Smith. So these are the different names it will show you, and joining date also it will show you that which date it has joined. So this will show you in this library system. And loans table, if you see in the this example loans table, it will show you the loan ID. It will show you the ID, and book ID FK, it will show you ID 1, 2, and member ID also it will show you, loan date it will show you. These are the few examples you can just go through in this relational database model. Now here the books table contains the information about books, and the member table contains the information about the library members. And the loan tables tracks which books are loaned to which members. So which member, the which book is for loan to the which member, it is assigned to the which member. These are the different type of tables which are followed by this relational database models, and it will tell you about that which is owned by the which member and what is his ID number, his or her ID number, and it will track the information about the which person it is given to, that book is given to which person. So the loan ID in the loans table is primary key which will help the book ID and the member ID are the foreign keys. So referencing the books and the members tables respectively. So this is how in this relational database model, if you see that, it will show you in the form of the tables and columns. So it gives us the information about the different authors and the book IDs and the titles with the help of these tables and column, which will help us to find out the information very easily in this relational data model. So ACID is one of the most important part in this relational data model, which will tell us about the uh, atomicity and consistency, isolation and durability. So how much durable it is and how far it is consistent, and it will give you at least the final results, whether failed or succeeded. That all information will be given by this transaction part in the ACID. So relational database model is basically dealing with the columns and the tables and the rows, where you can see this examples also, which will be dealt by the tables and columns. With the help of this library system, you can see in the library system we have seen that many tables will be there with the help of the book ID, author's ID, and the publisher year, which year it is published and which number it has taken and where it can be tracked. That all information can be managed by this library system with the help of the relational database models. Okay, so these are the few examples you can just go through about this relational database model. About this, and here it will help us to even find out very easily when the data is saved in the tables and columns. It will be easy to maintain the data. It is easy to find out the information about the persons whichever they are using this information for the any kind of purpose. So this was about the relational database model. So these are the few references which you can go through to find out the more content about this relational database model. So you can just go through this MNG Ready book by the BS Publications, which is Remote Sensing and GIS book published by BS Publications in New Delhi, or you can just go through this contents in this links and find out more information about it, about this relational database model. So I hope you understood about the relational database model, which is mainly dealing with the rows and columns, and it is very much helpful in the central database system. Like library is a central database, so where the central things are maintained, there you can just use this kind of database model for the any kind of purpose. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.